Alrighty, so we need to get started in chapter 4. Feel like we're probably a little behind right now, so we need to probably gonna have to push a little bit. So I'm gonna be trying a little bit something different with you guys. This is actually out of your D text in which I am sharing with you guys, in which I can do a few other things with it. Okay, so I can write on here. Um, you can stop. You can also go back on yours if you want to look at some of this, but some of the examples here are pretty good. Plus, there's some things I'm going to point out to you that you can go back later, look at, go through them. Um, and again, there's a few things that we can also use for your calculator too that I'm going to show you on here. Okay, so chapter 4, okay, is about polynomials, and there's quite a bit of things in which we're going to be dealing with. So in these polynomials, we're not going to be dealing with linear anymore. We're going to start with quadratics, okay? And if you remember, a quadratic function has to have an x squared to it, okay? So when we look right here, okay, you look here and you see that anything with a square in it, highest exponent, highest degree, is a quadratic, okay? So A, B, and C are just going to be numbers if they're there. Okay, you have to have an A though, because you have to have the x squared. So something like x squared minus 2x minus 3 is a quadratic. This too, even though there's a negative in front, doesn't make much difference. Okay, and remember our shapes. Our shapes of quadratic is a parabola. Now, if I was to put this right here, I guess I can't move that. If I put this here, yeah, oh, try to highlight it for you. Okay, we take this equation, put it in your calculator, you're going to get this picture, okay, with these x values and these y values and these ordered pairs, okay? So those things you can put in, okay? If I put the other equation, the negative 2x squared minus 8x minus 3, notice our picture goes down, but it's still a parabola. All quadratics make that parabola. We talked about that in an earlier unit, okay? Domain is all real numbers, goes forever to the left, forever to the right, and your range is always, if it's here, a range is negative infinity, arrows pointing down all the way up to 5. Closed. Okay? Now, what do we know about the parabola? This is a piece right here that I do want you to make sure that you guys see. This whole box here, these are all your characteristics. Okay? These are things that you can find without actually plugging into your equation, okay, into your calculator, okay? If A, remember that front number right here, that number there, if A is positive, it always opens up. If A is negative, it's always going to open down, okay? Your vertex is its turning point, okay? If it opens down, here's my vertex right here. If it opens up, your vertex is right there, okay? This is a maximum. Can't write very well. This is your maximum. This is your minimum. Okay? And then your axis of symmetry goes through here. Always goes through your minimum or your maximum. Whoops. Is a vertical line. I can't do a vertical line. Vertical line goes through there. That's your axis of symmetry. Okay? So it always goes through. If my minimum is here, my axis of symmetry is x is equal to 1. It's that number right there. If your vertex at negative 2, 5, your axis of symmetry is x is equal to negative 2. It's always the x value. Okay? Those are things that we can deal with. Get rid of all this. My dotted lines aren't very good, huh? Alright. Alright, so let's go to your next page. So, two different forms for quadratics. The first form is what's known as what they call standard form. Standard form is this right here. This is my standard form. A times x minus h squared plus k. And if you remember circles, okay, that h minus h, if it's a minus, h is positive. If it's a plus h, then it's negative, okay? So if we look down here, go back here, down here, here's my problem. Okay, this is in standard form down here in example 1. Here's my h and here's my k. So my vertex is going to be at 3, 5. Here's my h, here's my k. So my vertex, because it's a plus 2 there, is a minus 2. And your h is a negative, so it's a negative 4. The k stays negative, but the h here is always opposite signs. Simple as that. That's that nice little rule that we also used in circles. All right. So that just explains all of that. Okay. Sketching a parabola and a vertex. These are really good to be able to get your vertex and stuff. Okay. So if we go back up here, and let's look at this self-check here. So as I look at this self-check, notice here's my h and here's my k. There's my vertex. If I was to graph that, this would be -5, -4, correct? So I would have a point right here. Now, when I look here, notice that's positive, which means this opens up. Again, you put this in your calculator, you're going to graph it, right? But where's my axis of symmetry? Axis of symmetry is going to always be x is equal to, and it's always your x value, -5. Okay, so it would be right here. There's your axis of symmetry. Yeah. There's my symmetry at x is equal to -5. Okay, so those are all things, again, we want to be able to handle. Gotta hit it. All right. So watch these videos, they are very helpful. All right, so graphing from standard form, this kind of things we already talked about. And again, you can watch this video, it's actually pretty helpful. Now you won't be able to probably click on my video, but you can go back and look at it in your own e-text. Okay, actually click on it for me when you see my video and see if it actually works. I don't think it'll work, but give it a shot. Okay, so that's graphing from your standard form that you're going to be able to do. Okay, so be able to find all these pieces. So let's look at this problem here. If we get to my annotated here, so let's say we're going to take our grid, boom, boom, there we go. All right, so we're going to graph just some ideas here. So first and foremost, where's my vertex? My vertex, oops, I need to get my vertex is going to be at -1, -8, which is going to be -1, -8, which means my axis symmetry is at x is equal to -1. Now, why is that important? Because a parabola is symmetric. Okay, so we want to, because it's symmetric, we want to be able to deal some things here. So we have this point. Okay, now What are things I can find? X-intercepts. Well, x-intercepts, if I set this equal to 0, okay, which means I'm going to move the 8 over and then divide by 2. So if I move the 8 over, that's 8 divided by 2 is going to be 4 is equal to x plus 1 squared. How do I get rid of a square? We square root both sides. So in this x-intercept, I'm going to get 2, come over here, is equal to x plus 1. But we're also going to get negative 2 is equal to x plus 1. Because when I do the square root to both sides, we get a plus or minus right there. All right, so when I solve this, I'm going to get x is equal to, move that, subtract 1. We'll get a 1. Subtract 1, we'll get a negative 3. So we're going to have a negative 3, an x-intercept, and at 1, an x-intercept. Okay, and then the y-intercept, you put 0 in for x. So if I put 0 in for x, we're going to get 1. 0 plus 1 is 1. Square it. This is 1. 1 times 2 is 2. 2 minus 8 is 6. Negative 6. So we're going to get x-intercept, the y-intercept at x, negative 6. Now, why is that important? I have a dot here. If I have a dot here, that means I also have a dot over here because everything's symmetric. And that technically, folks, is enough for me to draw. Wow, that's pretty good. My graph. And there's my graph, which is something we would have done in class. Okay, now can you check that with your calculator? Definitely. And again, using your calculator is actually going to be where most of you are going to be doing it, especially online right now. Okay, so if that went fast, I have to, before I go to the next page, I have to erase all this. If that went fast, pause, rewatch it. Okay, and there's no problem with pausing and rewatching and going through some of these other videos. Okay. All right, so that kind of went through all of these steps here. Okay. All right, so now how do I graph from general form? And there's a lot of things of graphing from general form that you can deal with. Okay. First and foremost, know that general form is this form here, ax squared plus bx plus c. Okay, some call it standard form. The book first calls it general form. Okay, so when I look at something like this, down here in example 3, that's general form. Okay, you're going to be able to find vertex and all this other stuff. My main thing is for you to be able to find the vertex. Okay, to find the vertex, you can do all this completing the square. It's not a problem. You can do all this. But I tend to come up with a better way of finding it. Okay, I'm going to go to example 4. Here is a form. I want to find the vertex. What we're going to do is we're going to find the h value or the x value of my vertex by this little formula, negative b over 2a, because this is my a, bad a, this is my b. Okay, and I think the easiest way to find the vertex of something like this is using this little formula. B, which is negative 5, we have negative 5 over 2 times negative 2. All right, so negative 5 is going to be 5 all over a negative 4, which is going to give me a really nasty x value of negative 5 over 4. Negative 5/4. Okay, now why do I say that's nasty? Is because to find the y value of your vertex, you're going to take this value and plug it back in. Okay, And so you're going to go negative 2 times negative 5 over 4, square it, minus 5 times negative 5 over 4, plus 3. Okay, now this is going to be 25 fourths, or 25 sixteenths, sorry, times 2. So it's going to be negative 2 times 25 over 16. And this is going to be plus 25 over 4 plus 3. If it was me, I'd throw that into the calculator and find it. If not, this is going to actually be negative 25 over 8 plus 50 over 8 plus 24 over 8, which is going to be negative 25, that's 25, it's 49 over 8. Okay, which is actually it is reduced, 49 over 8. Okay, so there's my vertex. Now, which way does this open? It opens downward. Some things I just want you to know. It opens downward. And where is the axis of symmetry? X is equal to negative 5 fourths. Now, if it's negative 5 fourths, here's the other thing. If it's negative 5 fourths, negative 5 fourths, and up 49, here's my vertex somewhere here. And if it opens down, how many x-intercepts is it going to have? It's going to have 2. Now, where are they? You'd actually have to go find them. Okay? Again, all of this stuff can be done basically on your calculator. And let's see here. Ah, good. I'm just going to use that. Somebody told me that worked better. All right. So, again, finding your x-intercepts. Let's see, maximum and minimum points. All right. So, how can you find, using your calculator, your vertex? These steps will work you through. This actually works all yours except for those of you that Inspire. You'll have to look up the Inspire. Okay? But these steps can show you how to use your calculator. All right, now why does that come in handy? Well, in these last examples, word problems does come in handy, in which they give you problems in which you have to actually find your equations. Okay, so if you talk about this problem here, this ranch problem, it says you're having 400 feet of fencing, you're enclosing into this rectangular. Okay, so there's 3 sides. And they want to know what the largest area is going to be. Well, area is going to be length times width. So if I have length times width, here's my length, here's my width. That means I'm going to do, we're going to do x times 400 minus 2x, which is, that would be the area of this, which means now you have this quadratic. And they want to find the maximum area. Well, how do you know you're going to have maximum? Okay, you know it's going to be a maximum because which way does it open? It opens down, which means we're going to have a maximum. And the maximum area is going to be the y value of your vertex. Okay, so how do you find that? Well, you can go find your x value and then plug it in and get your y value. You can use your calculator and find the maximum, and it'll be the y value of your maximum. Okay, in this case, if you were to find your x value of this, now would I find x value of this equation? I would do negative 400, that's your b value, over 2 times negative 2, which is your a value, b over 2a, negative b over 2a, it's 400 over 4, which is 100. So my x value is 100. And then you plug that back in. So 100 squared times a negative 2 minus 400 times 100. So this value here is going to be 20,000. And that's the maximum area this can grab. Okay. Now, in the other example, they actually give you the equation. Here's the equation. They want you to find your minimum cost. Well, how do you know it's a minimum? A value is positive. That means it's going to open up. So my minimum cost is going to be the Y value of your vertex. That's what I'm looking for. How do I find that? I would use your equation. In my case, I'd use my calculator. But you can find your your X value, which would be 210 over 2 times a half, which is 0.5. That's a half right there. Okay, negative, negative. So that's going to be 210 over 1. So this value is going to be 210. And then you plug this back into all the x's, square it, here, and your Y value ends up being, I believe, 4,200. And in that case, it'll be dollars. Don't forget units, even on the other one. Okay? All right, so that, I believe, is everything from 4.1. I hope this helps. And we want you to make sure you can always go back and look at this, okay? All right.